lesson 8.1, only 4 questions. Let's get her done. Use, this is number 1, your graph might look different from my graph, but the process is the same. Use the graph to find the solution or solutions, right? We could have one solution or two, or none, of the related equation x squared minus 2x plus 2 equals 0. Great news about this problem. They graph it for you. All you need to do is find where what? How do we find?
The solution.
Right, but where do we look when we're looking for the solution to a quadratic equation? What?
X-axis.
The x-axis, very good. We're looking at the x-axis. Let's put our magnifying glasses on and look at the x-axis. What do we notice about that, the parabola in relation to the x-axis? It's not touching it. It's not, there's no vertex on it. It's not intersecting it with the little curvy curves. What does that mean?
0.
What?
No solution.
No solution. If it doesn't touch the x-axis, it doesn't have any real solutions. So we go over to our little multiple choice here. We skip A because there are no solutions, and we click B. And then we get some encouragement. What? Good question. When we show work, basically it would be an explanation, a written explanation. And I verbalized the explanation. Give me, I'm not saying like, and you should have listened. I'm asking you, how would you explain the reason that there are no solutions? I'll start the sentence. There are no real solutions because, now, before anybody says it out loud, I want everybody to fill it out. You can always cross it out or erase it when you're done. Finish this sentence. This is your explanation or your work shown. There are no solutions because, and you're going to finish that sentence. Take 1 minute to finish that sentence.
How do you spell the
Parabola?
Yeah, parabola.
Whoops, nope, not parabola. Parabola. It's really parabola, but I like to say parabola.
How do you spell line?
Line, L-I-N-E, line. We should have a spelling bee at Dayspring. The Dayspring spelling bee. That'd be fun. All right, finish that sentence. There are no solutions because, you write it down. Did you write it down? Angeli's sentence and Ricky's sentence are totally different. They are both correct. That's the beautiful thing about a written explanation. It can be in your own words.
Can I tell you my sentence?
I'm going to come read it. Is that question two? This, I would totally accept that as, I would totally accept that because I know what you're saying, but I'm going to talk about why that's like a little not, it's just that we have to like we have to edit that just a tiny bit to make it like really good. Abby, what am I going to do with you?
What? You can read it.
I did read it.
Yeah, that was a good one, right?
It is not accurate, but we're gonna go over it.
No solution because the x-axis isn't on the line.
What?
I mean, no, what is it called?
X-axis is the
Do you mean the parabola?
Yeah, that thing. Yeah, that
Okay.
thing.
Really?
Okay. Callie, your answer is totally different from Angelie's and Ricky's. All three of you are correct. You're all saying the same thing. Totally correct. This we're gonna talk about.
What about me?
We're definitely gonna talk about that.
Yeah.
How does an x
That's great. Totally different from the other four. Totally correct.
Is the line at, is this touching the angle or the side? I can't tell.
Is what?
Is that?
I would say the angle.
But
Yeah,
Looks like a side.
calm
I would
down.
say the angle.
What is like, I don't even having that ever.
What segment is it again, Brent?
Like, okay. Stall.
I don't know.
But do the view an example, and then it will like give you more information about that. Okay. I think that it would be a really good idea to analyze some of these, okay? If I told you that your answer is totally correct, I'm not gonna analyze yours right now. I will do it when we're done. Start with you. There are no solutions because yours is like almost there. Actually, let's start with somebody who's like totally off. You wrote, there are no solutions because,
'cause
The-
the parabola.
no, you wrote,
Abby, you wrote the x-axis is not
Well,
the
the
line.
same thing, bro.
You wrote the
so you're saying the parabola is the same thing as the x-axis?
Yep.
Is that what you're saying? That the parabola is the same thing as the x-axis?
Nope.
There are no solutions because, and you wrote the,
The parabola is not on the line.
okay, I'll give you that. Let's use your new one. Parabola is not on, I'm gonna put in quotes, the line.
You're close.
Now, I'm gonna ask you a question. I see a lot of lines there. What line are you talking about? Be specific. The parabola is not on the line.
Access.
What?
Access.
Axis?
What is it called? The thing like.
You wanna come up and point to it?
The 0 point.
That's.
So you're talking about a point now?
No, the thing with 0. You see where the 0 is?
Oh, I see where the 0 is.
Yeah, that thing.
You're talking about the origin now?
Yeah, the origin.
So you're saying that there are no solutions because the parabola is not on the origin?
Yeah, because the little bottom part isn't like on
So are you saying that in order to have a
the
solution,
y-axis.
the y-axis?
Yeah. It's not on the y-axis.
It does intersect the y. Abby, I want to introduce you to the y-axis and how the parabola does intersect the y-axis.
No, like where it ends.
Here?
No, on the thingy.
Come here.
No, the two thing. The thing right
Go
there.
show her.
Come
Where
here.
where the curved thing is. This part.
Here?
No, down one. That,
Here?
Yeah, that thing.
What do you want to call that?
That's not the
Starts with a V, Abby.
vertex.
Vertex. Okay, so we've got a vertex here, and what do we want to say about the vertex?
It's not lined up with the y-axis.
Oh, so if this was shifted over a little bit and the vertex was here and it went like that, then it would have a solution? What would that solution be? What's the solution to this one then? Emily O, tell me why this parabola still wouldn't have a solution. Okay, so yes, and kind of need
Because
to
it's not
adjust.
on both sides.
No, Abby, just pause things for a second. So I switched over to Emily because I want to incorporate what she said. Emily said there are no solutions because, so Abby, just no. Emily said there are no solutions because it's not on the x-axis, right? She said because the parabola is not, I'm gonna put on. There we go. The x-axis. And what I want to ask you, is the only way to have a solution for it to be on the x-axis? Is that the only way to have a solution? Does this have a solution or solutions? Does this parabola? Yeah. So we don't say on, because on implies it's like sitting on it only at one point. But we can have a solution whether it's sitting on the x-axis or going through it. Right? So we're going to adjust that. And let's come up with a better one. There are no solutions because the parabola. Angeli, tell me what you wrote. Isn't touching the x-axis. Is not touching. Whoops.
And you said the x-axis is not
Touching the x-axis. You could also say the function is not touching the x-axis. You could say the graph of the function is not touching the x-axis. Or you can just say the parabola is not touching the x-axis. Did anybody use another word for, or another phrase instead of saying not touching the x-axis? What did you write, Callie?
I didn't say parabola. I said line because I thought of it as a line.
You think of a quadratic function as a
I'll
line.
replace it, but like
Okay.
it's a line. I said like the same thing as you. It's not funny.
It's not touching? Okay. And then, Ricky, what did you say?
There are no solutions because there is no x-intercept.
Very good. There are no solutions. Another way to say this, there are no solutions. So this is correct. The parabola is not touching the x-axis. There are no solutions because there are no x-intercepts, and there are no x-intercepts because the parabola does not touch or intercept the x-axis. Melanie, what did you write? There are no solutions because
The parabola doesn't touch the x-axis.
that's what you wrote? Oh, great. So you had the same one as this, totally correct. Did I do yours yet? Okay. And then I did Callie's, yours. Okay, I want to do yours, and we're gonna look at that a little closer. I want you to read it exactly as you wrote it.
Yeah, Missy.
Tell me.
She didn't write it.
I did.
Okay,
I said the parabola.
read it.
There's no parabola. And like,
Okay. So this is what I meant to write. I meant to write like there, like.
There's just no parabola. I don't see any orange parabola right here. There's
No,
definitely
I
no
forgot what
curvy
it meant.
orange parabola with
I
arrows
forgot
on
what
it.
it meant.
Forgot what meant?
A parabola.
Parabola.
A parabola, it's just the name of the shape, yeah. Okay, so you said because there is no parabola. Okay, what did you mean to say because there is no?
I'm saying like
There are no solutions
it's
because,
not supposed to like be off the line. Like it's supposed to be on the line. It's supposed to be off the line. Like
what? It's supposed to be on the line, it's supposed to be off the line? It's like, it's alright, man. It's like, as long as you're just like either on the line or off the line, man. Just like whatever you want, man.
It's supposed to be on the line, but
Well, that's what Emily said, and how did we adjust that? She said,
it's not touching the line.
right,
X-axis. The x-axis.
right. So it's supposed to be on the line or going through the line. So we would just say it's not intercepting.
Okay.
Not the line, the x-axis. We would say the x-axis. All right, anybody else need to pick on?
I mean, we already did too.
Yeah, we already picked on everybody. All right, good. So did we get this? That you could say there are no solutions because the parabola or the function is not touching the x-axis, or there are no x-intercepts.
Okay.
Use the graph of the x-intercepts. Use the graph of f of x to find the x-intercept of the graph and the zeros of the function. Okay, the wording of this is very interesting. It says use the graph, which we'll move over to in a second, to find the x-intercepts of the graph and the zeros of the function. We know what it means to find x-intercepts, right? We know how to find x-intercepts, y-intercepts when we look at a graph. But it also is asking for the zeros of the function. Let's pause that one for a second and just focus on the x-intercepts first. Then we'll talk about zeros of the function. Okay, so it says, what are the x-intercepts? It also specifically says, type ordered pairs.
What is it? Oh, what is it?
If we need to type ordered pairs, does it say separate them by commas?
Yeah.
Yep, use a comma to separate answers. So this is how it's gonna look. An ordered pair, comma, an ordered pair.
Okay.
It says find the x-intercepts. Well, I do not think it could be more clear. Not only does this graph intercept the x-axis at 2 points, but they put 2 huge bright blue dots where that intercept happens. Emily A., give me the first, or I should say on the left side, the ordered pair for that x-intercept.
So the x.
Intercept.
Yeah, x
Is?
intercept is 0. Wait, no? Yeah. Well, it's gonna be -3. The x intercept is -3, and the y is 0.
Yes. Okay, so the x-intercept as an ordered pair would simply be -3, 0. I think you're in the mode of like, I have to explain it, unless you were kind of like a little over-explaining that one. But the x-intercept would be -3, 0. And then Abby, what would the other x-intercept be?
+3, 0.
I think you're just, look a little closer at those numbers. It might be different on, your graph might be different.
No, it's not.
What?
This one is not.
Well, it might be different on hers.
She just yeah.
Can you, if you need to come closer, Abby, I want you to look at my graph.
+5, 0.
Positive 5, 0, she got it.
It's the same for everyone. No, it's not.
Yes, it
No,
is.
it's not. I have different numbers.
Okay.
For the first one, it's -2.
Oh, okay. So this would be a tricky one to explain. I would simply explain it as,
I want the comment with.
I would simply just say, identify the ordered pair where the parabola intercepts the x-axis. It's a very simple explanation. There's nothing deep to it. To find the x-intercepts, identify the ordered pair or ordered pairs where the parabola intercepts the x-axis. Those are my x-intercepts. The next part of the question says, is it gonna let me go on without typing this? Now it says, the zeros of the function are x equals blank. It says use a comma to separate for answers, implies that there are more than one or two answers. The zeros of the function. That is kind of a vocab word or vocab phrase that we talked about yesterday. Zeros of the function. Why are they called zeros of the function? It's like, does that mean the answer is 0? The zeros of the function are 0. What does it mean by zeros of the function? That's, it's okay. That is a true statement, but it doesn't answer the question, why is it called zeros of the function? The x-intercept, the x value of the intercept are not zeros. So why are they asking for zeros of the function? What do they mean by zeros? Why would they say zeros? Why aren't they saying, give me the ones of the function or the twos of the function?
Oh, because of the thingies, there's zeros.
What are zeros? The x?
I mean the y.
The y values of the x-intercept are always 0. So that's why they call this the zeros of the function. The zero, asking for the zeros of the function is the same thing as asking for the solution. Very good. And I talked about this in class, that sometimes you're going to get what is your last name? Oh. I like do not listen to people's last names like that.
What about mine?
I know yours, because I,
Robert.
Emily N. But there are still some people where I'm like, huh? Okay, shh. So, what did Angelique say, Callie? What did she say? I said when they're asking for the zero of the functions, they're asking for the, she said it, I repeated it. What did she say? No. Ricky, what did she say? The solution. If they're asking for the zeros of the function, they're asking for the solution. But you might say, but didn't we just find the solutions because we just found the x-intercepts? Yup, we just found the solutions. The only difference in answering these questions are the way they are written. When it asks for the x-intercepts, we write x-intercepts and y-intercepts, Abby, as ordered pairs. When it asks for the solution, we drop the zeros. And we just write the x values. So how would we write that, Emily O? How would we write that the zeros of the function, or the solution of the function, are x equals blank, comma, blank? Really? And let me back up on what I just said. I said, these questions are actually asking for the exact same thing. They're just written differently. Because we know that the solution, or zeros of the function, are the places where the x-intercepts are. So it's the same thing. If I ask you for the solutions, you're gonna look for the x-intercepts, right? But we're not gonna write the solution as ordered pairs. We're gonna write them as the x values. That's it. Do you think that you had trouble answering that because it was like too easy? It was like too obvious, right? Sometimes we think that, well, it's the math homework, and math homework is usually hard, so it can't be that easy to just grab the x values and write them down here. But it is that easy. Are you guys getting this?
What?
Flippies!
Oh,
We should make Abby a shirt that says Flippies.
It's like,
Yeah.
which question?
You want to miss this question? Or do you want to wait till we're done? We have 2 more questions. Solve the.
I didn't work.
What?
Did
You know this answer?
So the first answer.
Okay,
But the
2 things. Shh, 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 shh. You know the answer, but you don't know me very well after all this time. If you know me by now, you know that, you know what? It's about the process, not about the answer. You know, I know the answer too.
But I was going to say the second part is confusing.
Okay, the second part of the question is confusing. Is there a part 2?
Yes.
Okay. All right, well, let's start with part 1 and let's do the process. Solve the quadratic equation by graphing the related function. Okay? Yeah. Well, this quadratic equation does give us, it automatically gives us a piece of information that we can apply to the graph. What piece of information does this graph give us that we can automatically plot?
It's at -1.
What is at? What do you say it's at? The y-intercept. Okay, here is our y-intercept. Is anybody confused as to why this quadratic equation is missing one of the terms? We normally have ax squared plus bx plus c. This one just has this and this. There's no bx term. That means b equals 0. Very good, you remember that from yesterday? So there's no bx term. That's okay. It's still a quadratic equation because of the second degree. It actually doesn't need this, it doesn't even need this to be a quadratic equation. Yeah?
For the last one, I got the numbers right, I just put the parentheses.
So you're skipping ahead?
No, this was the last one.
Oh, the previous one? I thought you meant for the last question on the homework. I'm like, why are you doing that? Just email me and just tell me that you got it right, okay? So I can mark it. All right, so we're missing the bx term. No big deal. It actually makes it kind of simple. Okay, this -121 does represent our y-intercept. The good news is we don't have to graph it on our own. We just have to choose which one has a y-intercept of -121. This y-intercept is positive, right?
Yeah.
This y-intercept is, this y-intercept is positive. This y-intercept is negative. This y-intercept is positive. How do we know if it's positive or negative on the graph?
It's above. If it's above the origin, it's positive. If it's below, it's negative.
Very good. If it's above 0, it's positive. If it's below 0, it's negative.
Sorry, my brain.
And out of these 4, 3 of them have positive y-intercepts. Only one of them has a negative y-intercept. So what do you think the answer is? C. Well, that was simple. I didn't even need to figure out anything else. Now it says the solutions are, okay, we're gonna have to zoom in on this to get those solutions. Let's pop it out. What? How are we supposed to get those solutions? Okay,
It goes to 5.
I can tell you how. So it's really hard to identify what this point is, right? Let's estimate, just to get a good idea of what it is. If this goes to -25, we could say this is 5, 10, 15, 20, 25, right? So this would be -5, this would be -10, this would be -15. What would this be about? It could be -11, right? possibly negative 11, could be negative 11.5 or something like that. And then of course, if this is 5, 10, and 15, 20, then this could also possibly be positive 11, possibly 11.1. We don't know exactly, right? So another way to determine it exactly is to use a table by saying, well, if the equation is x squared minus 121 equals 0, if we want the y value to be 0, and we always want, I know you're zoning out, we always want our y value to be 0, good. She was paying attention to my last sentence. We always, when we're looking for solutions, we always need the y value to be 0 because it has to be on the x-axis. So the y value has to be 0. So if we want the numbers that make the y value 0, think about what x has to be so that when it's squared and you subtract 121, you get 0. In order to subtract 121 to get 0, what does x squared have to be? 121. This has to equal 121 in order to subtract 121 and get 0. What number squared will get you 121? 11. Good. What's the other number that when it's squared will get you 121? Negative 11. Does that make sense? So that confirms that our solutions are negative 11 and 11. Negative 11, comma?
No, it's like I can't put commas over it.
What?
I can put a period.
It says use a comma to separate the answers needed. Take each solution only once.
You have to put a period and then a 0 and a comma. And then 11.
There you go.
Yeah, that's weird.
I literally just did it.
Negative 11, comma 11.
Wait, word. You got to have the
Excellent. They loved it. They ate it up with a spoon. I don't know what you're talking about, Willis. All right, last one. We can do this. Solve the quadratic equation by graphing the related function. Remember, this wording simply means it's giving you the equation, meaning it's equaling y or equaling 0, and graph the related function, meaning change this to be f of x equals x squared minus 4x plus 4. They mean the same thing. This is an equation. This is a function. They mean the same thing. This is just what we graph. Okay. So I'm going to graph it on here. What is my y-intercept? 4. What? What did you say? Why negative 4?
Because if when you do like the ax plus bx, like plus
ax squared plus bx plus c. Which term is our y-intercept? No. What's our y-intercept? C. That's our y.
That's like in a slope intercept they
Slope intercept, no. You're thinking of axis of symmetry. In the axis of symmetry, we use B and A, not C. C is our y-intercept, always has been, always will be. So positive 4 is our y-intercept. That's all we know so far. We can also tell if it's a happy parabola or a sad parabola. What's it gonna be? A happy parabola because A is positive. Now, going on to what Emily was saying, she was like, but what about the axis of symmetry? She loves axis of symmetry. It's a joke. Huh. Math jokes, best. Awkward laughter, awkward silence. Axis of symmetry. Axis of symmetry. 2 times a under negative b. Very good. Now we say the axis of symmetry is x equals, because it's a line that goes through the x-axis, 2 times a under negative b. So let's fill in our values. Negative what? Negative what?
4.
Every answer I heard was wrong. We need a negative what?
Negative 4.
Negative 4. Yes, I said a negative 4 because it says negative b. b is negative 4, so it's a negative 4. Do we get that? And all that means is it cancels out to a positive. No big whoop. Over 2 times a, well, we said that a is positive 1, so 2 times a, 2 times 1 would be 2. Negative times negative is, negative times negative is positive. Positive 4 over 2 is what? Positive 4 over 2? Yes, why did you say negative? Because we just said how a negative times a negative cancels to a positive. So the negatives are gone, and 4 over 2 is 2. That's our axis of symmetry. I'm going to go draw it, because it's fun. You get to draw a dotted line. It's not part of the parabola. It just shows you where the parabola has its symmetry. So if this point, this y-intercept, is not on the parabola, doesn't that mean I can figure out another point on this parabola just by doing what? This is the axis of symmetry. What does symmetry mean? What? No, symmetry doesn't mean line. What does symmetry mean?
It means it's equal on both sides.
Yeah, it's the same on the other side that it is on this side. No. Anybody? Okay, if this is where the parabola is symmetrical, then what does that mean about graphing a point based on this point? Yes, Zach?
It would be positive 4x.
Very good. You would go, well, if it's 2 units to get to the axis of symmetry, then it's 2 more units to get away from the axis of symmetry. A parabola is symmetrical. The other point will be the same distance from the axis of symmetry on the other side. Do you guys get that? You do get it? Okay. I'm still missing my vertex though, so I'm going to use my axis of symmetry, x equals 2.
Attention learners and instructors. Right now we are under a tornado watch.
Oh,
a
for real?
tornado watch has been issued.
Oh.
You can continue with normal activities, but we are always watching. Please be prepared to act quickly. If doors are opened, please close the doors. You should not be sitting near any windows. And if you are outside, all outdoor activities will be canceled until further notice. You should be inside a building. Again, this is just a tornado watch, so you can continue normal activities. Thank you.
Let's continue our normal activity. Yep.
Remember yesterday it was supposed to be a hurricane day? It was supposed to be,
Yes.
and it was also, I think it was also supposed to be today, but then.
No, we were supposed to be back to school today. Anyway,
Yeah. Yes.
guys, I have 2 minutes. I have 2 minutes. Be quiet. How do we find the vertex using what we got from our axis of symmetry? It's tricky. It's hard to remember. Sometimes I forget. It smells like potatoes. How do we, okay. Do you agree that the vertex is an ordered pair? Or the vertex has an ordered pair? It's a coordinate point, right? It's somewhere on this line. Do you agree that it's a point up?
Yeah, she finished.
I don't care. No packing up. It's distracting.
I'm just cleaning up.
No cleaning up. It's distracting. Look how distracted I am. When I get distracted, I keep you longer and later because it's fun. here's our axis of symmetry. Do you agree that the vertex has to be on the axis of symmetry? Okay, what does that mean for one of the coordinate, one part of the coordinate pair? Emily? If the vertex has to be somewhere on here, can you tell me at least one part of the coordinate pair?
0.
Hello? Yes? Sure. Okay. Nope. Okay. If the vertex has to be somewhere on this line, yes, we know that the x value of the vertex has to be 2. Because if this line, if all of the points on this line will have the x value 2, then the vertex has to have an x value of 2. We just don't know the y value of the vertex yet. How can we figure out the y value of the vertex if we know that the x value is 2? It could be anywhere. It could be 100, it could be negative 1,000,000. How do we know? How do we find it?
Are you still on me or?
Anybody, just
Okay.
anybody who could get us to lunch. Yeah. Solve what? By doing what? Good. Plugging into the original function, we're going to find the function of 2. We're inputting 2, and then we have 2 squared minus 4 times 2 plus 4. Then we solve it. We put the 2 into the machine and see what comes out. The output is our y value. 2 times 2 squared is 4. Minus 8 plus 4. 4 minus 8 is negative 4 plus 4 equals 0. So the function of 2 equals 0. When you put in a 2, what comes out is a 0. And if you're like, I said 0, that was a coincidence. It won't always be 0. Here is your vertex. In order to graph, I just said, if you go, I said 0, it was a coincidence. It will not always be 0. Okay? To graph a parabola digitally, all you need to do is select the parabola tool and graph the vertex and one other point, and boom, you've got a parabola. Callie, early dismissal. Have a great lunch, everybody.
Wait, wow, I
What?